In this lesson, we'll talk about three main subjects. First of all, we'll give a practical definition of TDD and we'll explain what a development microcycle is. We'll then spend most of the lesson showing what that means with a concrete example. I have two goals for this lesson, showing you the rhythm of TDD and showing how through a succession of unit tests it's possible to derive clean and compact code. Let's now get to the example which constitutes the body of this lesson. Let's propose we implement a transformation of a number from decimal to Roman notation. For example, 27 is represented by the characters XXVII, 691 by characters DCXCI, and so on. You can find a lot of adequate descriptions of the algorithm on the internet. Here I'll take for granted that you know how to perform the transformation and you just need to code it. For this lesson I've chosen Eclipse in its commercial reincarnation MyEclipse and Java. I have defined a project Roman with source folders source and test into which we'll put application and test code respectively. Let's then use JDK 1.6 and JUnit 4.5, and I'll take for granted that you know how to move around in Eclipse. Lastly, here you can see some shortcuts for the most common refactoring operations and Eclipse features that I'll be using during the lesson. Let's start by creating a test package, in which we'll define a class Roman test. The package is called tv.thinkcode.tdd. That's it. And now the class. Created through Eclipse automation. Roman test. In the test folder. Here it is. Good. Our first objective is to get the elusive red bar. In order to do so, we have to find the simplest test that sends us in that direction. So the first thing that we had better test is maybe how our system behaves trying to convert the number 0. Therefore, let's write a test whose name is 0 is empty string. This makes sense because for Romans the number 0 didn't exist. That is, it didn't have an explicit representation, so it seems most correct to convert it into an empty string. Let's assert that instantiating a Roman initialized with number 0 and converted to a string, we get, as a result, an empty string. But by doing so, though, the code doesn't compile. In particular, the system doesn't know about the class Roman. So we can ask Eclipse to generate it for us. The class Roman gets created in the application folder source. The code doesn't compile yet. We need to add at least a constructor that accepts an integer number as parameter, but we avoid adding any additional code, obviously. Our goal now is to execute the test given that the code compiles. Here we have the red bar. Our next goal is to write just enough application code to make the test pass, that is, until we get a green bar. The rule is just the bare minimum, without worrying about code quality at all. Some authors say, free the pig inside of you. Because this is a degenerate case, it's easy to implement toString by directly returning the value that we expect. Let's see what we've done. We've written 25 tests, 19 of which clearly guided the development of our application code. While developing, we've applied 5 refactoring operations, both to test and application code. It's worth noting that when you have to implement an algorithm like this, it's quite normal to perform several iterations of the microcycle with little refactoring, or focusing on special cases like those related to the keys in the map. But in any case, we've asked ourselves how to improve the code at every step and every time we've seen a way to do it, we have done it. In our next lessons, we'll deal with less algorithmic problems, and refactoring will emerge more clearly, or I'll simply control the pig in me less. All of this has required less than 40 minutes of development without considering all the informative panels discussed during the lesson. So we can clearly say that the microcycle of TDD is certainly strict and rapid. The time that occurs between writing 2 consecutive tests is typically less than 5 minutes when no legacy code is around, or even less, like 1 or 2 minutes. The development is entirely guided by tests. The tests are the development engine. The way we perform the microcycle naturally brings us to ask ourselves if and how we can improve the existing design by applying targeted refactoring operations. The most lucid examples are, in my opinion, introducing the map and getting rid of the keys array. In our future lessons, we'll talk about more juicy themes dealing with concepts like dependency injection, mock objects, responsive design, maintaining legacy code, evolving TDD through new ideas like behavior-driven development, and so on. The topics related to TDD are vast and stimulating, so don't miss our future lessons. See you later.